Okay, in this video, we're going to take a look at a few more examples involving the normal distribution. So in example 4, it says the length of a pregnancy is normally distributed with a mean of 268 days and a standard deviation of 15 days. It says a baby is considered premature if the length of the pregnancy is in the bottom 3%. We want to find the number of days that separates premature babies from those that are not premature. So we have a normal distribution with mean 268 and standard deviation 15. So if we were to identify the mean in the normal distribution, so it should be in the middle, so 268 is there. This 3% represents an area, so it's the bottom 3%, so it's an area on the left of 0.03, right? So we need to convert the percentage to decimal form, so divided by 100 to get 0.03. And in this problem, because we're given an area and we're asked to calculate the x value, unknown x value, we need to use the inverse norm command. So x would be inverse norm. Right, so the area is already a left area, so that would be 0.03. The mean is 268, and the standard deviation is 15. Okay, so in this problem we use the inverse norm command. So the area is on the left is 0.03, the mean is 268, and the standard deviation is 15. Okay, so when we do the calculation, we had 239.79. It's measured in days. Okay, so that's what we get as this x value here. And again, it makes sense, right? Because the area is pretty far to the left, so the x value should be a bit less than the mean. Okay, so let's take a look at example 5. It says a human body temperatures are normally distributed with a mean of 98.2 degrees Fahrenheit and a standard deviation of 0.62 degrees Fahrenheit. If a person's body temperature is in the bottom 0.01% or top 0.01%, then the distribution is at an unhealthy level. So we want to figure out these x values. Okay, so first of all, again, these numbers are given in percentages, so we have to convert it into decimal form, right? So 0.01 divided by 100, divided by 100 would be 0.0. I mean, this is in scientific notation, but it's 0.0001, and bottom and top would mean left and right, right? So we have to calculate two separate x values, so x1 and x2. So first for x1, this is already a left area, right? So that would be the inverse norm, 0.0001. The mean is 98.2, and the standard deviation is 0.62. So x1 would be equal to so we enter in the parameters. The mean is 98.2, 98.2, and the standard deviation is 0.62. And we can calculate it as 95.89 degrees Fahrenheit. Okay, so that's the bottom value here. Again, the mean is in the middle, which is 98.2, and then we want to calculate this other x value. So we have to use the inverse norm again. However, when we use the inverse norm, it should be a left area instead of a right area. So the left area is 1 minus 0.0001, which is equal to 0.9999. Right, so here we calculate the inverse norm. The left area now would be 0.999, the same mean, and the standard deviation. Okay, So we get the other x value, x2. So I can just repeat this command, inverse norm again. I replace the area by 0.999. And I can calculate it as 100.51 degrees Fahrenheit. Okay, so so that's what we get calculating the inverse norm, right? So again, when it's shaded to the right here, we have to switch to a left area before doing the calculation. Okay, so now let's continue to example 6. So it says IQ scores are normally distributed with a mean of 100 and a standard deviation of 15. So we want to calculate the range of IQ scores that describes the middle 80% of the population. So I've drawn in the normal distribution diagram here. We're trying to calculate the area in the middle. So in these types of problems, it's a good idea to sketch the normal distribution diagram so you can visualize what's going on here, and it'll help you set up the calculation. Right, so in this case, the middle area is 80% or 0.80. So we need to figure out these two x values. So let's call this x1. Let's call this x2. So what is this left area here? Right, so if the middle is 0.8, then the remaining unshaded region would be 0.2, but I have to split it in half, right? Because I have a left piece and a right piece, and they're the same. So the left area would be 0.1, and the right area here would also be 0.1. Okay, so if I want to calculate x1, I use the inverse norm again, because we're calculating an x value. The left area is 0.1, the mean is 100, the standard deviation is 15. So x1, now I can just put it into the calculator. So 0.1, mean is 100, standard deviation is 15. So you get 80.7767. Okay, so now let's go ahead and calculate x2. We're still looking for an x value, so that means we use inverse norm. Again, this number has to be a left area, so instead of 0.1, I use the complement, which is 0.9. And so now applying the calculation, left area now is 0.9. I get 119.2233. Okay, so basically, the middle 80% of the population has an IQ between 88.7767 and 119.2233. Okay, so these are some examples where we use the inverse norm command to calculate these x values for the normal distribution.